All right, continuing with the first example, part 3. So we wrote all of that out, okay? Now, we can use the calculator to help us with this. It'll go much quicker. All right, so again, this is for everybody, okay? And this is the only way that will work if you've got an older calculator. If you got a newer one, I'll show you when I'm all done with the example where you can go. All right, so everybody can practice this. All right, go to your calculator, go to list 1 and list 2. In list number 1, we are going to type the observed values. Okay, the observed values in list 1. Again, 7 students got 5s. 13 students got 2s. 7 students got 3s. 6 students got 2s. And 2 students got 1s. In list 2, we're going to put the expected counts. Okay, so we expect out of that class 5.33 or 5.355 students to get 5s. We expected 7.7 to get 4s. We expected 8.68 to get 3s. We expected 6.93 to get 2s, and we expected 6.335 to get 1s. Okay, now we can have the calculator do all of the work for us. Okay, if we go over here to the top of list 3, okay, we're going to go ahead and have the calculator figure out the observed minus the expected squared divided by the expected. All right, here we go. So parentheses. Now, the observed are in list 1, so we need to go second number 1 minus. Okay, the expected counts are in list 2, so second number 2, close it. Okay, we want to square that. So again, it's observed minus the expected squared. Now we're going to divide by the expected, and the expected is list 2. Okay, there it is. Now, if we hit enter, it will give us all of the observed minus expected squared divided by expected. Okay, now that we have the values in list number 3, we have to tell the calculator to add them up. So what we want to do is we want to go to second stat. Okay, we want to go to math. And then we want to pick number 5 that says sum. Okay, except we don't want to be in this screen. We want to go back to our home screen. So let's start that over. So second quit, get out of this screen. Again, go second, list, math, pick number 5, sum. Okay, now tell it to add list 3 together. Boom, there it is. Okay, so that is our chi-square or chi-square value. Now, first I'm going to show you with the table on finding what the p-value is. So we're going to go to table C. Okay, our degrees of freedom here, okay, is actually going to be 4. Because again, there were 5 values. Take one away, all right? Now, again, our chi-square for this one was 7.57. So we're going to go to degrees of freedom of 4. So we're looking in this row. Okay, and our chi-square is 7.57. So you will notice, ladies and gentlemen, that 7.57 is between 6.74 and 7.74. So that means our p-value is somewhere between 0.15 and 0.10. Okay, now we don't know it exactly by looking at the table. So this is where we would want to go ahead and use our calculator whenever possible. But that's how you would use the table to figure out your value. All right, so let's go back to the calculator. Again, this calculator method works for everybody, even if you have an old one. All right, so now what we're going to do is we're going to go second vars. Okay, so again, we have a bunch of different things in our menu. Okay, you need to know what each one of these represents. Well, not all of them. I didn't teach all of them. But if we go down here, okay, look at number 8. Okay, look at number 8. Okay, do not use number 7. Do not use it. That one's PDF. We don't want PDF. Again, we want CDF. Remember, CDF is cumulative distribution function. So we're going to pick number 8. Now, your lower bound. Okay, your lower bound here is the actual chi-square value. Okay, so 7.57, comma. Now you want to pick a large value. Okay, now 100, believe it or not, 100 is not as large as you should go. Whoops, we don't want to put a comma there. We want to go to upper bound. Sorry about that. Go to upper bound. So we don't want to put 100. We actually would like to put 1,000. Okay, we want it really big. And our degrees of freedom here is 5 minus 1, which is 4. Okay, paste it in. There it is. All right, so you can see, let me scroll back this way. If you've got a really old calculator, you don't actually do that. This will show up on your screen. Okay, I hit the left arrow a little too often. So you can see chi squared CDF 7.57, comma, 1,000, comma, and then your degrees of freedom. Okay, hit enter. And now we're going to get the exact value. Okay, we already saw from the table that it was somewhere between 0.15 and 0.10. Okay, well, there it is. It's 0.109. All right, so let's go back to the problem. Okay, so we got, whoops, wrong one. Sorry about that. Problems, spare me. Okay, sorry about this. It is not cooperating. There we go. All right, so again, we went this CDF 7.57, comma 1,000, comma 4. Do not write that on the AP test. And we get a p-value of 0.108. Okay, or let's just put 0.11. Okay, close enough, 0.11. So that is not that significant. So we can say there is not enough evidence to reject the hypothesis at the 1% and 5% level. However, with a p-value of 11%, there is some evidence to show that they did better than the national average. Okay, they were pretty close. I mean, think about it. Again, the smaller the p-value, the more significant it is. Granted, they didn't reach the 5% level or the 1% level, but, you know, their scores were pretty good. So we could say there's a little bit of evidence there to show that they did better than the national average. Okay? Now, if they would have been less than 5%, then they blew the test away. They were way above the national average. So that is the first example of the chi-square test. Okay? Continuing with example number 2 on the next part, part 4.